Algebra 2, Chapter 13, Section 5, Solving Trigonometric Equations. Now, this is different than something you've done in the past. Something you've done in the past is it's like sine of theta equals 1 half. And we would use the arc sine or the inverse sine to find the value, and we'd go, that happens to be 30 degrees. That is part of what we're doing. This is just part of it. So using the sine inverse to find the 1 half to give you theta, and you find out that theta is 30. That's just part of what we're doing. Because we're going to be multiplying and adding and doing all kinds of things with these different trigonometric functions to where you're going to have to separate them apart somehow. Um, One way you could visualize this is if you had a bunch of sine functions and a bunch of cosine functions and a bunch of tangent functions, or all these different graphs happening at the same time. Where would all those different graphs cross each other? So let's say you had a normal sine function, and then you had something like sine of I don't know, or 1 half theta, but the altitude's a little bit different. So you can see it intersects in slightly different spots along the way. That's what we're looking for, is those spots. One thing to keep in mind um, is the zero product property. Now, we use this property. We've used this a bunch, mostly in quadratics. What we were using it for in quadratics was, let's say you had x squared minus 9 equals 0. Oh, well, that factors down into x plus 3 times x minus 3 equals 0. Since the product of these two objects is 0, what we do is we set each object equal to 0 independently, and then continue solving. So when we get down to that stage, that's when we're working on our old stuff. Before then, we'll be manipulating it, usually trying to set up the zero product property. Not always, but lots of times. We might even be factoring some quadratics inside of it, or factoring some quartics even. So that's kind of a lowdown of what we're going to be doing. But basically, we're looking for the values of theta that always make it true for all the functions involved. All right. Example 1. Solve equations for a given interval. Now, this is important here, that it has defined where theta can be. Because normally theta bounces on forever, and there can be many different values of theta where they intersect. We'll talk about that in a minute. Right now, we're just limiting this to the first and second quadrant, right? 0 to 180 is all up in the first and the second quadrant. Okay. So, let's go on from there. I have sine theta times cosine theta minus 1 half times cosine theta equals 0. First thing I notice here is that there are two terms, the sine cosine term and the 1 half cosine term. That would just be something like 3x plus 3 equals 0, something like that, right? It's just, there's two terms there. There's an x term, there's a non-x term. In this case, the x would kind of be like the sine. Doesn't matter so much, except that I can see that if both these terms have a cosine in them, then I can factor a cosine out. It is a common factor. So cosine theta times sine minus 1 half. Oops. Forgot my sine theta minus 1 half equals 0. And now we have the situation that I mentioned before. We have the product of two things, cosine and sine theta minus 1 half equals 0. So that's when we apply the zero product property. The cosine of theta equals 0, and the sine theta minus 1 half equals 0. Well, cosine theta is 0. When I think back in my unit circle, cosine is 0 in one spot at 90 degrees there. So I'm going to say for cosine of theta of 0, theta equals 90 degrees. Now you could also say this or do the inverse function here, and that would give you the same result. Up next we have sine theta minus 1/2 equals 0. Well, I'm going to get the sine theta by itself, so I'm going to add 1/2 to both sides. And I have sine theta equals 1/2. Now, I know in the first quadrant, sine theta equals 1/2, I'll mark it in green here, at 30 degrees. That's when sine theta is 1/2. But because I'm also allowing examples in the fourth quadrant, I know that's also true here for 150 degrees. I'm just using my unit circle knowledge. So, if that's the case, then theta can equal 30 degrees and theta can equal 150 degrees. So, our solutions, whenever we have theta equal to 30 degrees equal to 90 degrees, so 30 degrees for the sine, 90 degrees for the cosine, and 150 degrees for the other side. Now, let's say you don't believe that. Well, here's what I'm going to do. I'm going to go to my NumWorks simulator here, and we are going to do a calculation. I'm in degrees. Okay, so I'm going to do, let's try 30 degrees. Sine of 30 degrees times cosine of 30 degrees minus 1/2 times cosine of 30 degrees. Oops. Cosine of 30 degrees. And this whole thing should equal 0. And it does. And I could even go back, steal that function, and instead type in 90 degrees in each of those spots. 90 degrees. Oops. 90 degrees. Execute. It's a 0. And I mean, if you don't believe me, you can try it yourself, or I can just do it real quick here. We'll do it for 150 as well. And maybe you're thinking at this point, like, well, that maybe it's always that because he's got 3 different solutions here, and it's all coming out to be 0. Let's go ahead and steal that last one and try it for 15 degrees. When that's not our solution, right? So when I hit enter, I should get anything but 0. And you see, I do not get 0. Okay. I was just checking all the answers on the calculator. Theta is 30, 90, and 150.